So today's topic is really what we call text mining for social signals. Now, in the class notes, it's labeled just as text 2, and it's incredibly boring. In fact, these are two papers that show a really fascinating thing. So this class is really two papers, both by Eric Gilbert. So he's the first author here, along with his thesis advisor, Carrie Carihalios. So she's at Illinois, University of Illinois. Eric Gilbert was her student back in 2008, 2009 when they wrote this paper. And now he's gone on, he's at Georgia Tech, and Kari is still there. What's fascinating about these two papers, though, is that they both use text analytic methods to measure something that you might not have thought you could do. So we're going to look at the first paper, and then we'll look at the second paper in a minute. But this first paper, Widespread Worry in the Stock Market, is really about how they use a text analytic process to create what they call the anxiety index. Now that's what they call it because it's measuring the sort of level of uncertainty and worry and concern that people have when you look at a lot of different blog posts over a particular time. The really interesting thing about it is that they show that this anxiety index actually predicts stock market value, right? That is, it's a leading indicator. So we'll talk about that just a little bit. But it's based on this notion. If you remember from last week, we talked about text mining or text data mining. So this whole field of text analytics is really growing rapidly right now. And this paper is actually a little old now. It's from 2009. We'll see some more recent work in just a little bit. But there's a ton of work going on here. And this was sort of the first suggestion that you could actually mine millions of blogs all at once. Now, when we talked about this last week, we talked about analysis of small pieces of text, single messages and so on. This is a text analysis of large quantities of text, giant numbers of blogs, and how you can do that. Okay, so what we're trying to do with all of this work is to either extract data, but in this case, we're trying to extract opinions and sentiment. That is, how do people feel? If you remember I Feel Fine system from Sepp Kamvar and Jonathan Harris a few weeks ago, they were taking these little fragments and then using it to plot how people felt emotionally in response to world events or rain or whatever. We're trying to do this similar kind of thing here, but looking at overall level of anxiety. So it's a slightly different focus. So this paper has three key ideas. First off, you can estimate widespread over these large numbers of blogs, these socially expressed emotions. Now, what they're measuring here is anxiety. You could measure the opposite of that, which would be sort of joy or happiness or long-term concern or immediate anger. There's a lot of ways, a lot of things you could measure. They're trying to measure anxiety. Okay, they show a method to do that. Second thing they show is that the anxiety index is an indicator that leads the stock price. Now, we'll talk about that in a second, but they found this really interesting inverted correlation. When their anxiety goes up, expressed in blogs, then the overall stock price goes down, and it leads by about a couple of days. And the third point is that mood or affective expressions can be seen in large online social groups. And this can anticipate, as we just said, stock prices or overall aggregated stock prices. Now, the question you might be asking, why aren't these guys millionaires? Right? If you can predict this stuff, why haven't you made $1 billion in the stock market? The answer is that they predict the overall aggregated values. When you're buying and selling stocks, you have to buy individual stocks. And this does not predict the motion of individual stocks. It predicts the motion of the entire market. So yes, there might be a strategy for using this, but it's not fine-grained enough to do it. It is an aggregated statistic. So in particular, the thing they found is that you get one standard deviation rise in the anxiety index, meaning people are writing saying, I feel worried, I'm concerned, I'm anxious. That predicts a negative 0.4% change in Standard & Poor index. Now, what's the Standard & Poor index? It's a group of 500 different stocks mostly large capital, heavily industrial stocks in the United States. There's 500 of them in a basket. And you take that average of all those stocks, or the sum of all those stocks, and you get that moving average. So this is you're seeing a 3-month S&P 500 index. So basically, it's a leading indicator that is one of the most important indicators of the performance of large industries in the US. And this also tends to be global as well, but there are other indicators. So for example, there's the Russell index in another part of the world. Not associated with me, just somebody else. Now, when you read this paper, we got this paper, right, by Gilbert and Carharlios. You want to understand, you should be approaching this paper with sort of 3 questions in mind. They have an anxiety index. How do they do that? How do they actually do it? What's the computational process? Second, does this thing really work? And third, really, is it even plausible? Does this make any sense whatsoever that people can affect the stock market or predict the motion of the stock market based on expressions like this? Let's talk about this third point first. Is it plausible? Yes, turns out it is plausible. It's plausible because previous work has shown that something like the change in the weather causes an overall change in the Dow Jones value. That's just a different index. Okay, that was shown in 2003. A little bit later, Tetlock and his friends all showed that pessimism as expressed in editorials in the Wall Street Journal can predict particular kinds of movements in the stock market. Okay. Then, of course, in 2009, Halvarian and Choi showed that how Google searches for specific items can predict consumer spending. So we also have, there's another paper about Google flu trends where we can talk about that, where socially aggregated information predicts real-world behavior. That worked out really well. And that's basically showing us that, yeah, this stuff really will work. So let's figure out, how do we do it? So these folks used a data set of 20 million live journal posts from 2008. So they're not using any really super current data, but they collected these live journal posts from January to June and August to September and November to December. So we were just talking about data cleaning. This is the kind of problem you see all the time. You notice anything problematic about this data set? There are big gaps in it. I don't know why the gaps happen, but the truth is lots and lots of data sets have gaps. And so if this were a class on data analytics or data statistical processing, we would talk about how to deal with gaps, but that's a different class. What they did to fill in is they used all the live journal posts from ICWSM. They collected it, they put together a data set, which is basically this data, and they tried to patch in the missing data. The bottom line was that they had 2,110,000 posts, 20,110,000 posts, full text. That's a lot of text. What do you do? So let's talk about this. So an interesting issue to think about when you're collecting any data set, so for your project or for any kind of data set analysis you do in the future, you want to think about how could this data set be biased? What could possibly go wrong? One thing to think about for a data set like this is to realize that if you're looking just at blogs, you're probably looking at the blogger population, which is almost universally seen as a younger, technologically savvy, smart population. That's great, but it's not necessarily a broad or a random sample. So it's not representative of the population as a whole. It's representative of people who are a little bit more forward-thinking, a little bit younger. They're different. So why did they use just LiveJournal? Part of the reason for that is to try to minimize the blogger bias. So for example, Google has a blog platform called Blogspot, which is based on Blogger, which tends to be very technologically savvy people. LiveJournal, by contrast, has been around for a long time. It was one of the very first journaling or first blogging platforms. So they have a long history of this. And it's no longer really in the news, which means it's just kind of a day-to-day thing. People just use it. they don't grandstand on it. And so it's not subject to lots of swings and biases because it's appearing in the news or not. From a data sample perspective, that's really good. That's what you want. You want nothing really special. You just want everyday data. Another observation here, this third point, is that bloggers often write about their friends as well. It's more than just them. They might write something like, my friend Pedro was feeling bad today because it's a terrible day and his stocks all declined by 10%, whatever. So you're getting actually a somewhat broader sample than just the individuals. Okay, so how does this work? So if you read the paper, they basically say they built two different classifiers to do this. And they trained them both on labeled data. Now, we've talked about labeled data before. It's the gold standard. So the good part about that is that the labels come from the authors themselves. So Joseph writes a blog post and he says, oh, my mood is happy, or my mood is anxious, or my mood is worried. He labels it himself or herself. Okay? So that's the gold standard. The problem with that is that not that many blog posts have labels on them. So, but with 20 million blog posts, you probably get a few thousand. That's enough for training. So what they did is they built two different kinds of classifiers. So what they did is they tried the first one using what's called boosted decision trees. Again, this is not an algorithms class, so we're not going to go into that. But you can go read what a boosted decision tree is. It basically takes a bunch of terms. In this case, they used about 100 different word stems with features in order to classify the non-labeled blogs as anxious or not anxious or whatever. So they use terms like nervous, scared, interview. Wait, why is interview in there? Because people are anxious about their interviews. And so they discovered in looking through, hand labeling these things, that words like interview or midterm or test or final, those kinds of words make people anxious. And so they use that as criterion. The second method they built was a second classifier, C2 there, using a method called bagged complement naive Bayes. And there they used a much larger set. So they did it twice. In the second one, using naive Bayes labeling, they used a much larger, richer set, 48,000 words. So they went through and classified all this way. Now, remember we talked about Luke? This thing up here, LIWC, that's pronounced Luke. That's the linguistic sentiment classifier. Now, they could have just used Luke rather than doing this, but they wouldn't have had a paper, or it'd be a different paper. Anyway, they built their own, which is fine. But I'm willing to bet you $1 that they could have used Luke and gotten the same results. But like I said, that's probably a separate paper. So let's talk about what they had to do here. So here's the first key result. So they built these classifiers and then ran them over the data set. They've got 20 million posts, remember. So they've got some that they ran their labelers over it and labeled this thing appropriately. And what they found is that M2, their second classifier, the better one, actually does pretty well. So what you're seeing here is the difference of returns. That black line in there is the difference of returns between days. So it's the delta between day 1 and day 2 in this Standard & Poor market measure. So, okay. Then what you're seeing in that gold or that yellow line is the anxiety measure delayed by 2 days. So it's looking at the previous, what the anxiety level was 2 days ago. Aha! They find this anti-correlation. That is, when the anxiety level goes up, the market goes down. And they shifted it by 2 days in order to get them to line up. We're going to come back to this topic, so remember, you have to shift it in order to make sure that the thing is actually predicting what you think. Okay, that's what we call a lagged value or a lagged model. It's lagged by 2 days or 3 days or 4 days, whatever. Okay. What's interesting about this is you see this anti-correlation, or what's called a negative relationship. So in the paper, they call it these diamond patterns. Now, I highlighted 2 diamonds here so you can see it. So you see those red triangle slash diamond shape? I didn't spend enough time to actually make them diamonds, but you can now, once you see those two, you can see other ones. So there's one here, there's one here, there's one here. So their point is, when you see these diamonds, what you're seeing is anti-correlated or oppositely correlated measures. When the market goes up, the anxiety level goes down. When the anxiety level comes up, market goes down. So that's a beautiful result. Now, that's a beautiful diagram, but that's not enough, right? In order to make a really good paper, a really good argument, you want to test this. So the way you test for the value or accuracy of predictions is you use what's called Granger causality. Now, first, a word of warning. It's not really causality, okay? Forget that word. I mean, it's an overloaded word. So just think of it as the Granger test, but everybody calls it Granger causality. What it's really doing is looking at two different time series and to see if time series X predicts time series Y, you have to see this correlation in their values with a delay. So if you look down here, these graphs are not from the paper, they're from some other paper. So here we have a signal X, okay, it's varying with time, blah, 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 okay? Below we have another signal which is correlated. You see that peak right here is delayed by, in this case, what is it, 5 minutes or whatever, 5 hours, whatever it is, 5 days. Same thing kind of here. So a Granger causal test is a test you can use to basically take two signals and to see if one is correlated with the other one after a time delay. Okay, so that's what it is. And there's a R package to do this. You just pour in your two statements, your two data sets, and you can do it. And so this is the output from the R package. Basically, what you're seeing up here is this is the model with three different delays that they're measuring, and they're measuring to see which delay fits best. The cool thing is to look down here. This is the F statistic. Again, this is not a class on statistics, but the F statistic is telling you basically what's the variance here. And what you're seeing is the variance here is 3.0, which is pretty good, but the really important number is this thing here, P. So here the P value is 0.03. Now typically we like our P values to be 0.05 or less. This is less. This is awesome. This means that the result is probably not due to random variation. It's probably really due to the predictive power of your statistic. In this case, it's M2, which has the anxiety index. So if you compare this with M1, which is their other model, which doesn't have the anxiety index, it doesn't work. It's no good, right? So here, if you test M1 with the same statistic, it's not great at all. So what this means is that we have shown, as expected, that high anxiety, as measured by the mood indicated in the blogs, negatively affects the market. This is a fantastic result. Okay. Now there's some other stuff in this paper. Is this the one? Yeah, where they do Monte Carlo method modeling and all that. And I'm not going to talk about it because I kind of don't believe it. But what I'm curious about is what happened to my models. There it is. Sorry, I somehow skipped over this. Sorry, this is the slide that should have been before the other one. This is actually the expression of the two models. This is M1 and M2, okay? So you can pour in these models, these linear models, and the only difference between M1 and M2 is that M2 has this anxiety term here. So this is the anxiety measure as measured by their text analysis of the mood of all these blogs. So basically, they create a time series by running this sentiment analysis of theirs, creating a measure of the anxiety over the 20 million results, and then saying, oh, that's my data set. Now that's A, and then that's what you pour into this. This is M2. Okay? So the bottom line, after all these words, after all this stuff, the bottom line here is that having an anxiety measure makes it possible to evaluate the mood of millions of bloggers using these text sentiment mining techniques. This shows, I think, that you can tap into large numbers of people, of individuals' sentiment without any particular proxy. That is, without taking surveys or dialing by digits or reading intermediaries like op-ed pieces in the New York Times or whatever. So they have shown that this is what they call a Granger causal method for showing this relationship. And I think one of the fascinating things about this is how well they were able to quantify this effect size. A +1 standard deviation change in the anxiety index indicates a -4% change in the stock value, the S&P value. So what's interesting, I just find interesting about this is that you have to realize that there are investing experts worldwide that sell investor sentiment reports. These are basically documents you pay for that give you very wise advice about how to invest or not in the stock market. So what on earth could LiveJournal know about the stock market, right? So this is one of the most interesting parts of this piece of work. You can argue that the anxiety index has novel information because it's deriving information that's not from financial circles. So these investor reports are all people who are inside the financial universe, and they're looking at various indicators there. What this is doing is it's tapping into what people are actually saying. So as we've shown with this other work, like the Google Flu Trends or the other work that's done by folks at Google, it's clear that you can draw important conclusions about the data that people leave behind on the web, either through their purchase patterns or through their blogs, their tweets, or their Facebook posts. This particular introduction of the anxiety index shows that you can actually have these kinds of interesting economic models that reduce the need for these non-direct, intermediary-based kinds of analytics. Okay, so that's the first paper. Now, so in summary, this paper is basically telling us that you can do the sentiment analysis and use it in a really predictive and interesting way. This is what social computing is really all about, is measuring social behaviors through different methods, either through analysis of weak ties and strong ties, or through sentiment mining, or whatever their social data is, and then coming up with something fascinating we can argue about what's happening. Okay, I want to turn our attention to the second paper. This one is also by Eric Gilbert, and this is more recent. This is just a few years ago, published in CSCW. Now, CSCW is a conference and stands for Computer Supported Cooperative Work. So this is all about social computing for the purposes of work. And so in this paper, the title is Phrases That Signal Workplace Hierarchy. Now, what they're doing in this paper is how to identify, by an analysis of email texts, whether or not that text is going to a superior, your boss, or to not an inferior, but somebody who works for you, or a peer. Okay? What they did, and the reason I wanted to talk about this in the class, is that this is a very nice example of using an existing corpus, in this case the Enron email corpus, to extract what they call upwards relationships. So if somebody sends an email to your boss, can you figure that out without looking at their name, without knowing that it's going to the boss? That is the text of the email to a boss somehow different than the text of an email to a subordinate? Surprise, surprise. Yeah, it's true. Yes, you could determine this. That's what this paper is about. So I found this paper when it originally came out in 2012 to be fascinating. That's why we're talking about it here. So here's the key ideas of this paper. First off, the obvious observation is at work, hierarchical work relationships are important. That is, who's the manager, who's the manager's manager, and so on. When people write to each other within a corporate workplace, the words and phrases people use signal their dominance relationships. Now, I think I mentioned this earlier, but there's a very famous piece of work by Erving Goffman where he talks about this notion that people create their social identities as a performance. That is, they are acting out the role they think they should behave, they fulfill the role and behaviors that they need to satisfy. Remember many weeks ago, we talked about creating your social identity online, how you represent yourself. This is the same thing in the workplace setting. It's the same idea. And in this case, the expression of your identity is partly encoded in what you write, what you say in the email messages. Okay, so in this work, they use two different methods to identify these, quote, signaling terms and phrases. That is, they identify pieces of text in email that signals whether or not you're a subordinate or to its email to a manager or whatever. Okay, the two methods they use are penalized logistic regression and support vector machine. Okay, these are two classifying methods, and we'll talk a little bit about each. Now, here's a slide I just put in this morning because I only thought about it when I was coming into work, and I thought, you know, they pulled a little bit of a fast one, and I don't mean that it's a bad thing. It's just it's very clever on their part. But when they do this analysis of all these emails, all they're really trying to figure out is whether or not this email is being sent upward in the corporate hierarchy, and that's it. Everything else is labeled, is defaulted to not upwards. So it's a binary distinction. So when I first read the paper, I thought that they were actually doing three different classifications: email to a peer, email downwards, or email upwards. That's not the case. They're only looking at email and are trying to identify if this email is to a superior, to a boss, or your boss's boss. This turns out it makes a lot of the analysis a lot simpler. Now, in many corporate environments, you have a hierarchy. It looks a little bit like this. And in the Enron Corpus case, this is true here. We have a CEO who's kind of on the same level as a president. The CEO and president both have vice presidents, and they have directors. And so from top to bottom, this is sort of the layers of the cake. This is from the top of the hierarchy to the bottom of the hierarchy. So they had, you know, a couple hundred employees, each of which were in turn, at the very bottom, they were in turn managed by specialists. Specialists were managed by managers. They all reported and worked through an in-house lawyer and so on. So this is the bottom, this is the top. Upward is email from an employee to a specialist or to a manager, and downward would be the opposite, right? Makes sense. So the Enron Data Set, we've mentioned this before, and there's a link to it in the notes about the data project, but there's a link down at the very bottom here too if you're curious about this. Stored at CMU. So what happened is that Enron was a big company in the US that was, shall we say, an energy company. And what they actually did was they bought other energy companies, oil, gas, electrical, so on. And they would manage their performance and their intercompany sales and all this. So they were a management company that specialized in energy. So they were sued and they lost. And in the process, all of their email became public. So this is a weird thing in the United States. It just became public, and the consequence of this is it's the most studied email corpus of all time because it's 500,000 email messages. It's 151 employees, so it's small enough to be tractable, and it's a really famous case. So it's very clear what was going on because this data set has been analyzed a million different ways. And I will tell you, the bottom line is these people were guilty of immense amounts of fraud, and so it became a fascinating test case for social network analysis. Because this guy, Jeffrey Skilling, was the CEO. And you can see how groups of people worked together or didn't work together. Anyway, it's a fascinating corpus. If you're interested, I will give links in the notes later about some references to papers like that analyze this. But that's not our point today. Our point today is this is a nice data set where we can actually look at the data and try to analyze it in terms of what we care about, which is the message text about going upward. So here's what they did. They took these many messages, these email messages, and labeled the data with up or down. That is it going to a superior or inferior? Now wait a second. All right. Remember what they're trying to do is trying to develop the algorithm. That is, they're trying to train the classifier to determine whether it's going up or down. So what they did is they knew which position each person had. And so they would then say, oh, this is going from this person, an employee, to the CEO. That's up. Okay? So they had this, and that's kind of the gold data. They use that as the labels for the training system for the classifier. So they took these emails, they labeled them as going up or down. They removed all the replies, so it's just the email that's being sent. They lowercase the text, remove stop word, basically basic cleaning it up. They then broke it up into unigrams, bigrams, and trigrams. So they said, I'm not going to worry about sentences at all. I'm going to worry about individual words, pairs of words, that is bigrams, or trios of words, trigrams. Okay? They then did something interesting. They basically, and I'm sure they found this out by experimentation, but they then said, let's go through this whole set and discard anything that doesn't appear in more than 10 messages. So a word that's really rare only appears in, say, 2 messages in the entire corpus. That just gets thrown out. And their reasoning there is that's not going to be a useful signal because it's so rare. And they've got a point. They also then went through and discarded anything that was not said by more than 3 people. Again, it's interesting data, but it's not useful for determining a signal to train a classifier. Okay? And then finally, they had human raters actually go through and discard anything that is Enron specific. So there could be very common phrases like, go Enron go. That's not useful. Because we're trying, remember, to create a classifier that will do this extraction or labeling. And you don't want stuff that's specific to that particular company because it's just not relevant. Okay, so this is what they did. Took the data, cleaned it, transformed it in the way we just talked about, and then they ran their analyses. And they did, like I said, 2 different attempts. The first one we'll talk about in a little bit depth is they used their penalized logistic regression. Basically, what this means is that a penalized logistic regression is a regular old logistic regression, right? Which is just a regular regression that's using categorical variables. But it means the penalized part is that you add a penalty to certain properties of the regression coefficients. Okay, so you can actually, normally you just look for the optimum likelihood of each variable. But when you penalize things, you can say, okay, that's no good, so we're going to penalize that. So what it ends up doing is downweighting certain variables, and otherwise everything runs the way you would expect. So luckily enough, there's an R package to do this. You don't have to think about it too much. So here's what they find. The first observation is it really helps to know who sent it. Well, imagine my surprise, right? If you know where it's going, it's easy to label it. That's actually trivially true. But what's fascinating is that they found that these phrases, these n-grams, turn out to be determinative. They give you a lot of information, a lot of signal, but you might not guess what those are. That's the point of doing this analysis. What kinds of phrases? You might guess, but here's the answer. I'll show you the answer in a second. So this regression step, they run through this regression step, and what they're doing is they're taking all the variables, which in this case are all of the terms, the bigrams and the trigrams. Okay, each of those become a variable in this gigantic regression, and they're going to see which of those signal an email is going upward in the hierarchy. Okay, now we know it's going upward because it's, we have the labels. We know who it's to and who it's from. So what you need to do is compute these beta variables. Now, upper left corner, you can see I defined it for you. The beta variable, the beta value, is the measure of how strongly each contributor, each predictive variable contributes to the decision. Okay, so it's basically a measure of how much power, how predictive that is in terms of the label. Okay, so you're looking for these n-grams. And here it is. There's the answer, right? You run this giant analysis and you get out all these single words, these bigrams, unigrams, and trigrams, and associated with each one is a beta value. Now, notice here, there's two tables here. There's a table here on the left-hand side and a table on the right-hand side. The way to read this is this column right here is the phrases and terms that signify a message going upward. That's what the up arrow means. So these are signals of phrases in email messages that go upward. So the most powerful one is this: if somebody writes blah, 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 the ability to blah, 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 it kind of doesn't matter what the rest of the email is. It's almost certainly being sent upward, that is, to a superior. We see other variables like attach and other phrases like that we might, and the calendar, and so on and so on and so on. So it surprises me that you get these funny terms like shit in the middle of it, which are also messages to superiors. It's interesting. I would not have expected that. Now, over here on the right-hand side, we get equivalent, meaning peer or downward phrases. So this is basically, the right-hand side is all the stuff that's negative for predicting upward. Remember, this is a binary choice. So we have phrases here that are to peers or downward in the hierarchy. And this is, if you look in the paper, it's a giant table. It's a full page. And so here I've included the very bottom of that table. So on the left, you have table 2, which is the 100 most powerful phrases for predicting email that goes up in the hierarchy. Okay. On the right-hand side, you have the 100 most powerful phrases for predicting an email that does not, that is, goes to peer or goes downward. Now, this is all extracted from the data set. Okay. So what they've got, basically, is this way to run a filter over this stuff and get evidence that something is going up or down the corporate hierarchy. Now, what they haven't done is shown it that it works for anything other than Enron, but let's assume it works, okay? Now, what Eric Gilbert did was to basically then take all of these phrases and run it through Luke. Remember Luke? It's that same categorization system we have. So LIWC, linguistic word categorization stuff. He then had the Luke take all those phrases we just saw, run them through Luke, and have it tell you what category it is. Here's the interesting output. Of the phrases that ran through there, they used the Luke program, and they found that some huge fraction of them that were going upward are cognitive, that is, expressing something about thinking. Ones that are to peers and go down are 21%. Here, everything else is kind of, these differences are too small to be useful. It's only this one, only cognitive. People express cognitive actions more often to their peers or downward than they do upward. So this is fascinating, right? Because 21% of the non-upward phrases are cognitive. Things like I think, or did you know that, things like that. Things that express some internal thinking state. Well, only 16% of the upward phrases do. So they also do an interesting analysis of this, which is to take all of the texts and create what's called a word tree. And the way a word tree, or word tree works is if you look for all the sentences that contain the term thank in it, the most probable next word is you. That makes sense. The most probable next word after you is for. Font size here indicates frequency. So for example, thank you, exclamation point. Exclamation point is much less frequent than for, and much less, I guess that's it. Yeah, but you get the idea here. So you're seeing phrases here and there's a visualization of what the most common completions are. So in essence, what you're seeing here is that you can see that the word thank appears in the upwards part of the corpus a bunch of times and is a powerful predictor of sending it upward, right? It's an upward message. So here, this next slide, oops, there we go. So this is the same thing, except it's words at the end of the sentence. Okay. So here you can see all the phrases that end with blah, 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 talk. So you see the most likely one is, we need to talk. Huh. Well, this is indicative of a phrase that's going downward. It's not upward. Okay. So you see what's going on, right? So they also tried this SVM approach. The result is that they were able to predict upward at 70% accuracy. Truthfully, it's not very good. If it were 90% or 95%, and so we'll come back to this point a little bit, but it's interesting. So they basically tried two classification approaches: this, logistic regression thing, and this SVM thing. The SVM thing kind of didn't work. They put it in the paper, and truthfully, if they'd left it out of the paper, nobody would have noticed. But they wanted to report that they couldn't quite make it work. So this looks great, but it's not great. Did not work well. So here's what they found. Certain words and phrases, when they appear in an email, are very probably signaling a movement of this message to someone up in the hierarchy. This is the upward model. So for example, a word like attach. Here I have attached a document, a spreadsheet, or whatever. If you use it like that in an email, it's probably going upward in the hierarchy. Okay? Phrases like thought you would. It's a kind of a polite hedge in English. Oh, I thought you would do that. It's not saying you idiot. I thought you said you would do that. So, but that's the way of politeness marker that indicates that the email is going upward. Now, this is a fascinating linguistic observation that they do not do in the paper, but I'll speculate for you, is that politeness markers are probably more common going upward than downward in the hierarchy. But they didn't do that. Maybe that's a piece of research for you to do. Weekend signals. If you use the word weekend in an email, it's also another marker of upwards, with a suggestion that you're working really hard for the company, right? Or it sounds good. It's the same kind of thing. So what we're seeing here, if you go back to that original table, table 2, you'll see all those terms, all those phrases, those are all markers. And that's what this analysis found. Now, here are a couple of insights to close off the paper. So in the process of cleaning the text, they found this interesting side effect. So if you look down here, where it says, best regards, Jim, blah, blah, blah. This is a standard email. Now, when they cleaned it, they actually kind of had a bug, which is that they wanted to remove the dates. But what they did is that the parser actually left this term, WED, like the day of the week. So best regards, Jim, Wed, and this part would be removed, May 12, 2005. That part would be removed. So the classifier learned about this term, WED. The very surprising result is that they discovered when they did a time plot that more messages went upward on Wednesdays than on Fridays. So they did not pursue this very much farther in the paper, but it's an interesting thing to think about. Here's an interesting research paper to do in the future. Do people send upward more text messages, more email messages earlier in the week than later in the week? Is there a day-to-day difference? Based on all the data I've seen, I'm willing to bet that's true. And I bet if you could classify these emails, say you have your favorite email corpus, say from your company, you could probably show that same kind of result. Anyway, that's a sort of accidental side effect that they discovered. But that's what we call a seasonality, that is time-varying behavior based on, say, day of the week or day of the year or day of the month or whatever. So for example, for example, in Google, search queries drop off radically Friday afternoon. They come back up on Saturday, and this is a very weekly seasonal effect. Same thing with end of the year. Between, say, Christmas and New Year, purchasing patterns are radically different. Queries are very, very different. And of course, this varies by culture, by country, by language. But we get lots of things like that. An interesting thing that came out of this is some terms, like October, are also associated with upward. If you go into the corpus and look, you find that a lot of the terms like October are used in conjunction with planning end-of-year travel. So this is another kind of cultural embedding of knowledge. People travel at the end of the year, the fiscal year, in order to close deals or do whatever. So this is another kind of symbol or a signal that may be culturally embedded. And as we saw with the Luke tagging of cognitive messages, uh, people expose their internal state about thinking less going upward than downward. Now, this is another sort of accidental discovery, but when they did all these labelings, they discovered when they were cleaning the data that misspellings occur far more frequently in messages that are not going upward. Think about that. What it suggests is that when you send a message to your boss or your boss's boss, you spell check it very carefully. When you're sending it to a peer or downward in the corporate hierarchy, you just don't care as much. So there's an interesting research topic right there. Is misspelling frequency an indicator of social status? Is it an indicator of the meaning, the sort of posturing and identity that you create online? I suspect that's true. Again, this is not part of the paper, but it's an interesting research topic for the next paper. So let's go back to the SVM. Remember that kind of didn't work. So my guess is that they kind of messed up the training data for the SVM, because almost in the very last section of the paper, in the discussion section, they say, we constrained the data so tightly that the SVM had a hard time not overtraining. So when they increased the data set to 11,000 messages, the accuracy goes up to 91%. So it's pretty clear to me that they screwed up the SVM. And this is this very last line here, when they got up to 91% at the very end, that was too late for publication. They couldn't finish it in time. Anyway, that's the kind of thing that happens, you know. It's just one of those things that happens in real research. And part of the point of this class is to expose you to these kinds of things, because there's all kinds of stuff that goes on, and I'm helping to teach you how to read between the lines. So where do we go next? So with these kinds of classifier or predictive systems, you know, it's possible to think about building a predictor like this into your email system, you know, and being able to do something differently when you're sending up a hierarchy. So for example, if I'm sending something to my boss, wouldn't it be great if the email system said, no, you really want to spell check this, right? Because that's an important relationship, and that's a signifier of that. Or you could analyze emails for differences from expected behavior. For example, are there people in the organization that are differentially attracting more upward emails than is appropriate for their status? Imagine the lowest level employee is getting lots of upward emails. What's going on? So all of a sudden we can start to turn this as an analytic tool and start to understand what's really happening in a corporate hierarchy. Because one of the things we know from other social studies of social networks in companies is that the org chart does not reflect the reality. That is, there are people who are in positions of power that are lower down in the hierarchy than the email they get would predict. So this is a whole other topic for another day. But the variance, the difference between what's officially expressed and what's actually going on is huge. And this may be a way of getting data into seeing that. Okay? So I love these two papers, partly because I like the writing style, and it's just they have all these accidental insights, and it's just a fantastic thing. So let's talk for just a couple seconds here about what's coming up. So this is our last online class. Thank you, Pedro. Thank you for setting this up and making it all happen. But I'm flying into Zurich on Monday, and I will be there all week. I'll be actually in my office all afternoon, Tuesday through Friday. So if you want to come talk with me, please let me know, drop me an email, set up a time, we can sit and chat. But we have 3 classes scheduled. We have the first one on May 31st. And this is, I've scheduled 2 hours for this. I suspect what we'll do is spend about an hour and 15 minutes talking about this topic of searching together. And then we'll spend the last 30, 45 minutes talking about projects. It's sort of the last chance for people to, get really good advice and have time to go implement a change if they need to. Thursday, we have a regular class, and we'll be talking about this stuff, about the Livelihoods Project, using understanding, and this is kind of a reflection right back to the very first class. How do we understand what people do in reality from their social behaviors? And then, of course, last day is Friday, June 2nd, a week from today, and we'll be doing our project presentations. So, if you've got any questions, go ahead and ask me, email me. I'm always up and looking for things you want to do. Okay? How's that?